Okay, I'd like to talk a little bit about reading solubility curves. This is the third page in the packet, and this is what a solubility curve would look like. The way they make these is they will make a saturated solution. So they'll put some solid into a liquid, heat it to a particular temperature. So in this case, they might heat it to 10 degrees. And as long as there's solid sitting on the bottom, they will know that the solution is saturated. So they'll take out a sample. And when they do that, they take it out, they evaporate off the liquid, and then they measure the amount of solid. So in this case, they found, I don't know, that might be like 7 or 8 grams worth of, what are we at here, KClO3. Then they'll do the same thing at 20 degrees, at 30 degrees, at 40, and so forth. And then they can do that at temperatures in between, so you get the smooth line, which shows the solubility. So at a particular temperature, so at 10 or 20 or 30 degrees, if you have 100 grams of water, this is telling you how much solid you could dissolve. So if I were to have 100 grams of water and I wanted to dissolve some KClO3 in that water at 30 degrees and I had 100 grams, I would come up here, I would read this chart and I would say, all right, here's where it's crossing, bring it over, and it looks to me, that looks to me less than 15, I don't know, 12, 13, 14, probably 13, I guess. It seems to be a little lower than my circle there. I'd say about you could dissolve 13 grams of KClO3 in 100 grams of water at 30 degrees. At 40 degrees, the number's a little higher. To me, it looks like it's a little over halfway. So that might be, up here a little bit, so it might be 16 or 17. And then if we go up to 50 degrees, you'll see it's maybe 22. So if I ever say to you, how much can you dissolve at a particular temperature, you find your line, you find the temperature, and you read over. This tells you how much you can dissolve in 100 grams. Let's say I wanted to do 200 grams. So let's say the question was, how much KClO3 can I dissolve in 200 grams of water at 70 degrees? So I'd come up here to 70. I'm right here. I'd read this across. This might be 34, 35 grams per 100 grams of water. So for 200 grams, I would double that number. And then I'd say, well, then I should be able to dissolve twice that amount. So call that 34 times 2 might be 68 grams. If it was per 300 grams, I would triple the number. So just understand this chart is telling you how much you can dissolve at a particular temperature in 100 grams of water. And if it's asking for a different amount of water than that, you have to double it or what have you. Now, a couple of things I want you to notice. Notice most of these lines slope up. Sodium chloride here, my salt, fairly flat line, doesn't change a whole lot, but look at something like KNO3, very, very steep. KNO3 becomes much more soluble as the temperature goes up. Most of these solids are like that. Ki is just here. So if I said to you, what's the most soluble material at 10 degrees according to this graph, you would go up to the highest line, and that, of course, is Ki. If I said to you, what's the least soluble, you'd come down here to the lowest line, and you'd say, well, that's that KClO3 again. So again, you can kind of read this. You'll notice that most of them tend to go up. Now, there are 3 of them, and let me do these in a different color because I want to highlight these. There are 3, HCl, NH3, and SO2. Their lines are all sloping down. The reason is those are gases. If you remember, gases become less soluble as the temperature goes up. So as I heat up my solution, I can dissolve less gas because the particles are moving faster and they can escape more easily. If I'm dealing with a solid, solids become more soluble as the temperature goes up in general. And this graph kind of holds that out. Now, another way I could rephrase a question on this thing is I could say something like, at what temperature, if I have 60 grams of water, at what temperature would I have to heat the water if I wanted to dissolve let's say 60, well, let's say with the 60 grams. So let's have 100 grams of water. At what temperature do I need the water to be if I want to dissolve 60 grams of ammonium chloride? So that's NH4Cl. So now I'm coming backwards. So I'm going to read over here at 60 degrees. I find my NH4Cl line, which is here, and I say, where does that cross the 60 gram line? And it's right here a little bit before 70 degrees. So I would say maybe 68 or 69 degrees. So if I could heat my water to 68, 69 degrees, add 100 grams of it, I would be able to dissolve 60 grams of, in this case, NH4Cl. So I could ask you the temperature you would need, or I could say how much you could dissolve based on what you have here with these lines.